Hi, this is Mary. Today we're going to talk about complex numbers. First, we're going to find out what an imaginary number is. An imaginary number is defined as I, where I is the square root of -1. So it follows that the square of I, or I squared, is equal to -1. Let's do some problems. Express in terms of I. Example 1. I want to figure out the square root of -7. So the square root of -7 can be thought of as -1 times 7. If I split these radicals out, I have the square root of -1 times the square root of 7. Well, we know by definition, right here, that the square root of -1 is I times the square root of 7. Example 2. We could do the same thing. We could split this out as the square root of -1 times 25. But what I saw in this first problem is that the square root of my negative sign is I. So I have I times the square root of 25, but the square root of 25 simplifies to 5, and we write our answer as 5 times I. Example 3. I know that the square root of my negative sign is I times the square root of 18, but we should always simplify radicals whenever we can. So I have I times the square root of 9 times 2, which simplifies to I times the square root of 9 is 3 times the square root of 2. And we're going to write our answer is 3I times the square root of 2. Example 4. Now this one has a negative sign already out in front, so it's going to just tag along. And the square root of the negative sign is I times the square root of 75. We want to simplify the square root of 75. Now I will show you a trick on your calculator. I'm going to bring up my calculator. I'm going to hit my program button and bring up some programs. If you do not have these programs on your calculator, ask your teacher. But I'm going to use number 1, CPLX root, my first program. Press enter. It's going to ask for R, or the root. This is a square root problem, so I'll put 2, enter. The A is 75. Enter. This is a program that lets me simplify radicals, which is 5I times the square root of 3. And remember, we said our negative sign is going to tag along. Okay, a complex number always looks like A plus B times I. Notice it's got two parts to it. It's got a real number part, which is my A, and an imaginary number part, which is the BI. Okay, it should always be written in standard form of A plus BI. Well, we're going to see that we can add, subtract, multiply, and divide complex numbers. To add complex numbers, all we want to do is rewrite it without parentheses. So I have 3 plus 5I minus 2 minus 7I. Notice I have some real parts here. I want to combine like parts. So I have 1 combining my 3 minus 2, and I have 2 imaginary parts minus 2I. Example 2, we're subtracting two complex numbers. It's the same idea, get rid of the parentheses. 7 plus 2I. But to get rid of this set of parentheses, I need to distribute my negative sign. Plus 3 plus 5I. And all we're going to do is combine like parts. 10 plus 7I. We can multiply complex numbers. What we want to do is always simplify your radicals first, write in terms of I, and then multiply by using the distributive property or foiling when necessary. Let's do example 1. My square root of negative 4 simplifies to 2i. My square root of negative 9 is 3i. I'm going to multiply my 2 times my 3 to get 6. I times I is I squared, and remember that I squared is negative 1. So I have 6 times my negative 1 to give negative 6 for my answer. Example 2 is very similar. I have I times the square root of 10 times I times the square root of 11. Neither one of these radicals simplify, so I'm going to multiply my i's. I times I is I squared. Multiply my radicals, the square root of 110. Now remember, I squared is negative 1, so I have negative the square root of 110. Okay, let's multiply and simplify these. 7 times negative 5 is negative 35. I times I is I squared. Remember, I squared is negative 1, so negative 35 times negative 1. The answer is positive 35. Example 2, we're just going to distribute as we need to. Negative 15i minus 40i squared. Negative 15i. Now remember the I squared. What has it been doing for us? It has just been changing the sign and making it a real part. So this will be plus 40 because I would have had a negative times a negative to give positive. But we need to write it in a plus bi terms. So 40 minus 15i. Always put your real part first. Example 3, we're going to FOIL. F, negative 21, O, negative 35i, the inside minus 6i, and the last minus 10i squared. Simplify. Negative 21. I'm going to combine my like terms, minus 41i. And remember the I squared. It will change the sign and make it real to give a plus 10. Now I'm going to combine my real parts, negative 11 minus 41i. Now let me show you on the calculator that most of these problems can be done on the calculator. Bring it up here. I am going to do example 3 with my calculator, and I'm going to type it in just the way I see it. Okay, parentheses, 7 plus 2. I is right here above the decimal, but it's blue, so second decimal is I. Close, open, negative 3, subtract 5, I. Close, press enter. There is my negative 11 minus 41i. Let's do example 4 on the calculator. Parentheses, 5 plus 2i times 5 minus 2i. When I multiply these two complex numbers, I got 29. Notice the imaginary part does not show up on this problem. Okay. And let's do this last problem here. This literally means to take this complex number, 2 minus 9i, times itself, 2 minus 9i, because it's squared. But this can be another calculator problem. 2 minus 9i. Now, we could just type it out again, or we could use this x squared button right here, because what it does, it squares whatever's below it. And press enter. The calculator says the complex number is negative 77 minus 36i. Okay, so this lesson was about complex numbers. Thank you and have a good day.